Okay, so let's do these next two problems. These two problems are kind of very similar to what we did in part A. So in part A, what we said is that if you have something inside of the argument, you have to be very careful. So even though you only want values from 0 to 2 pi, it's sometimes easier to make them to solve for the general solutions with the pi k and the 2 pi k, as opposed to just doing it straight up. Okay, because sometimes you can miss some solutions. So what I'm gonna go ahead and do is solve these generally, and then we're gonna plug in values for the k values until we get all the values from 0 to from 2 pi. Okay. So first, let's start off by taking the inverse cosine. So let's get rid of the cosine by taking cosine inverse. So that's going to go away, and I'm left with 2x is equal to the cosine inverse of 1/2. So I need to look at the unit circle and figure out where exactly is the cosine, what angles are going to give me 1/2. So let's go here. So let's look at the angles that give me 1/2. So remember that cosine is the x value. So we want, what was it? 1/2. Okay, so we're going to look at 1/2. So here's 1/2, and here is 1/2. So those are my x values. So that means that my angles are going to be pi over 3 and 5 pi over 3. So pi over 3 and 5 pi over 3. Now what I'm going to do is I'm going to add plus 2 pi k. I know that we only want the solutions between 0 and 2 pi, but I'm going to add 2 pi k just in case I'm missing any of them. Okay, now what I'm going to do is I'm going to get rid of this 2. Okay, that's in front of it. So I'm going to divide everything by 2. Divide by 2. You get a 2. You get a 2. You get a 2. And you get a 2. So x in this case is going to be equal to pi over 6 plus pi k. And then the other guy is going to be 5 pi over 6 plus pi k. All right. So here is where the annoying part starts, because now we have to make sure that all of these are going to be in the interval. So let's first start off with pi over 6 plus pi k. All right, so clearly when I plug in 0, I'm just going to get x equals pi over 6, which clearly is in the interval from 0 to pi, 2 pi. So it's going to be, the first one's going to be pi over 6. If I were to make k equals -1, notice that this is basically already 30 degrees. If I go, I'm going to get negative, so I'm not going to get anything here. There's going to be nothing, none. Okay, so that one is below 0. Now let's plug in k equals 1. Let's see what happens. So I'm going to take pi over 6, and I'm going to add pi times 1. So that's going to give me pi over 6 plus 6 pi over 6. Okay, so what is that going to give me? That's going to give me 7 pi over 6. Oh, 7 pi over 6 is within the interval. Okay, so this guy's good. All right, so see that we would have lost this guy. Okay, all right, so now what about k equals 2? Am I going too far? Let's see. Pi over 6 plus pi times 2. That's going to be pi over 6 plus, okay, this the way that we write this will be 6 multiplied by 6. That will give me 12 pi. This is going to give me 11 pi over 6. Okay, so did I go too far? Not right. That should be 13. I cannot, I'm subtracting 13 pi over 6. Okay, so this guy clearly is way above it. So that guy's not going to be it. So that means that we're done. Okay, so this was the maximum. So 7 pi over 6. So we're all good. All right, so now let's look at x equals 5 pi over 6 plus pi k. All right, so let's start off with k equals 0. So clearly we get just 5 pi over 6. Okay, so 5 pi over 6 is another solution. All right, let's plug in k equals -1. Okay, so I'm going to have 5 pi over 6 plus pi times -1. So you get 5 pi over 6 minus 6 pi over 6. Okay, so what is this going to give me? This guy is going to give me negative pi over 6. Okay, so I went too far. Okay, so this is a negative, so that one's not going to be it. So now let's go with a positive one. So get 5 pi over 6 plus pi. That's going to give me 5 pi over 6 plus 6 pi over 6. That's going to give me 11 pi over 6. Okay, so that one is also here. So we would have missed that one too. Okay, so that's what we get, 11 pi over 6. And then obviously, I'm not even going to apply k equals 2 because if you look at where 11 pi over 6 is at, 11 pi over 6 is already at the edge. That means if I keep adding another pi, I'm not going to get anywhere. Okay, so what that means is that these guys are all of my solutions. Okay, so we actually, if we would have just solved it regularly, we would have only gotten pi over 6 and 5 pi over 6, which would have been wrong. So we were still missing these other two. So you got to do this extra work, okay? So make sure that you do this extra work. All right, so now let's try this one. So 2 sine of pi theta equals 1, okay? So let's first start off by dividing this by 2. So let's get rid of this 2. So we're going to get sine of pi theta equals 1/2. Okay, so now we want to figure out, let's take the sine inverse. So sine inverse to both sides. So this is going to go away. So I'm left with pi theta is equal to sine inverse of 1/2. Okay, so where is sine? Where do I get the value? What angles do I get 1/2 for sine? Okay, so let's go back here. Let me erase this guy. So now we're looking for sine. So sine in this case is the y value. We're looking for all the 1/2s. Okay, so here's the 1/2 and here's the 1/2. So that's at 5 pi over 6 and at pi over 6. Okay. So that's going to be at 5 pi over 6. Oh, at pi over 6. Okay, and I'm going to add 2 pi k and then 5 pi over 6, which is plus 2 pi k. Okay. All right, just making sure that I did that right. Yes, okay, that's correct. All right, so now all we got to do is let's get rid of that pi. Okay, so getting rid of that pi, divide by 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 pi. So you're going to get theta is equal to, so this guy's just going to give me 1/6 plus 2k. And this guy's going to give me 5/6 plus 2k. Okay, so these will be my general solutions, but remember, we only want all of the angles that are between 0 to 2 pi, from 2 pi. Okay, so from 0 to 2 pi, remember that? Okay, so now what we're going to do is we're going to go ahead and solve by plugging in the values of k. So we're going to start off with theta is equal to 1/6 plus 2k. Okay, now one of the things to kind of just know is that maybe since the pi's went away and we want this, another way to kind of think about it, especially when you want to put this in decimals, 2 pi is about 6.28. So as long as the numbers are between 0 to 6.28, you should be okay. So the first thing that you can do is you can plug in a k equals 0. So when I put in k equals 0, you're just going to get 1/6. Okay, so obviously that 1/6 is within that numbers. So theta equals 1/6 is one of the answers. Okay, if I plug in -1 in here, notice that the 2 is going to be bigger and I'm going to get a negative number, which is clearly less than 0. So that's not going to work. So now the next one, let's plug in 1. So I'm going to have 1/6 plus 2. Okay. Here you can use it in the calculator instead of finding the least common denominator, like I have. So this is going to give me about 2.16 or 2.17. So that one's good. Okay, so let me go ahead and just actually give me the actual answer. So the true answer is 13 over 6. Okay, and 13 over 6 is about 2.17, and that one's still good. So 13 over 6 is the solution. Okay, now let's plug in 2. Let's see if that works. So 1/6 plus 2 times 2 is going to give me 4. So when I do 1/6 and I add 4, I'm going to get 25 over 6. Okay, so what is that as a decimal? That's 4.17. Okay, so this one's still good. 25 over 6. Okay, now what about k equals 3? So 1/6 plus, when I plug in 3 in there, you're going to get a 6. So I'm going to have 1/6 plus 6. I'm going to get 37 over 6. And when I put that, I got 6.16. Okay, so this one barely made it. 37 over 6. So that one's good. All right. Now, clearly, because this is 6.16, adding another one is probably not going to do anything. Because if I were to take the 1/6 and then I added the 8, okay, you can kind of see that that one's going to be way above it. So that's not going to work. Okay, so then we're done there. And now let's go ahead and look at theta equals 5/6 plus 2k. All right, so clearly 5/6 is one of them. Okay, so 5/6 is going to be one of them. So when k equals 0, you get 5/6, and 5/6 is clearly in that interval. Same thing with the -1, that just doesn't make sense, so that was not going to work. I plug in the 1, so you're going to get 5/6 plus 2. Okay, so you're going to go ahead and do that. So 5/6 plus 2, that's going to give me 17/6. And if I do that, that's about 2.83. So this guy is good. 17/6. Then I'm going to plug in the 2. So 5/6. So I plug in the 2 in here, and I'm going to get 4. So I'm going to take this 5/6, and I'm going to add 4. I'm going to get 29/6. And if I do that, it's about 4.83. That one's still good. 29/6. And then I'm going to plug in 3 to see if that works. So 5/6 plus 4. Oh, that's wrong. Plus 6. Because I'm plugging in the 3. So I'm going to get 5/6 plus 6. Okay, I'm going to get 41/6. That's way above it. So this guy is not good. So these guys are all my solutions. Okay. So yes, very tedious. You do have to go through, or you have to go ahead and iterate through all of these different answers. So, and you can kind of see it if you're a programmer, why it would be good to know the formula and then have the computer just do it for you. Okay, so this is basically how you would go into doing these types of problems. So in the next video, we will do some problems that are a little bit more algebraic.